Hello everyone, welcome to this class. We will be discussing about resistors connected in parallel, and we generate a general formula for you to be able to get the total resistance in a circuit when resistors are connected in parallel. So what we do, we will begin from Kirchhoff's current law, voltage current law, which says that when there exists a branch, when there is a branch in a circuit, current will divide. Just like when water flows and it reaches a junction, water will split. So the same way, whenever current flows from the source, upon reaching a junction, it will split just like water. So what we are saying, if current, the total current I, which is moving from this particular voltage, reaches this junction, the current will split. That is why we are saying when it reaches this point, some current will branch to the R1, part of it will continue with the journey, and the one which has continued with the journey, upon reaching this junction 2, it will again split into two parts. One goes to R2 and another one goes to R3. So basically what I'm saying, according to Kirchhoff's current law, the current coming from the source, upon reaching the junction, it will divide into various portions. So that is why I've said current will branch to R1, part of it will go to R2, and another one will go to R3. So at the end of the day, according to Kirchhoff's current law, we would say the total current I from the source will be equal to the one going to the I1 plus I2 plus I3. Though it does not divide in equal amounts, it will depend on the resistances. Where we have more resistance, current going through that point is very small compared to a resistor which is small, where more current will pass through. So this is called Kirchhoff's current law. That is an equation for Kirchhoff's current law. Again, from Ohm's law, from Ohm's law, we know that current, the total current will be given by total voltage divided by the total resistance. By the total resistance, we know I1 will be equal to, remember in a parallel circuit, one very important feature you need to know, the voltage is the same across board, irrespective of the number of resistors, even if you have 10. So meaning if this is 20 voltage will pass here, 20 voltage here, 20 voltage here, because in a parallel circuit, voltage is the same. So the voltage across this resistor, for you to get I1, you will take the voltage divided by resistance. For you to get I2, you will take V over R2. For you to get the voltage, the current here, you will get the voltage divided by the resistance. So that is why I'm saying it will be V over R1. If you want to get I2, will be equal to V over R2. If you want to get I3, will be equal to V divided by R3. So that is from Ohm's law. If you substitute these formulas, if you substitute these values in equation 1, let us say this is our equation 1. If you substitute this in equation 1, so substitute the above in equation 1, when you substitute this in equation 1, this is what you will get. You, instead of writing I, we will write this. Instead of writing I1, we write this. So you will have V over R total will be equal to V over R1 plus V over R2 plus V over R3. Because voltage is common across both, you will factor voltage. V over RT will be equal to V 1 over R1 plus 1 over R2 plus 1 over R3. Those are the values we are getting. Sorry. We are getting 1 over R3. Once you are there, you can cancel out V on both sides, where you will get 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is now the formula for getting the total resistance. If you want to get the total resistance, it will be given by this formula. If you have a special case, in a special case where you have only two resistors, so this is the formula of getting the total resistance. I'm saying a special case where you only have two resistors, then we would say you would be having 1 over R2, 1 over the total resistance, over 1 over R1 plus 1 over R2. Remember, in this case, we were having the 3 resistors. So I'm saying if you only have 2 resistors, this is what will happen. So if you have these, you will take the reciprocal. This will be the same as if you take the reciprocal, if you take the LCM, you will get R1, R2. Then here you get R2 plus R1. R2 plus R1, that is what you will get. Remember, if you want to get the R total, so meaning 1 over RT will be equal to R2 plus R1 all over R1, R2. Remember now, if you want to get RT, you can take the reciprocal of everything. So if you want to get RT, will be the same as R1, R2 divided by R1 plus R2. This is a special case. That is a special case. If you are having two resistors, if you are having two resistors connected in parallel, what you do, you use a formula called product over sum. You multiply the two resistors, then you divide it by the sum of the two resistors. If you have two resistors in a circuit, you want to get the total resistance, you take the product of the two resistors, you divide it by the sum. So we call it product over sum. So we have generated the general formula of determining resistances, the total resistance for resistors connected in parallel. We shall now look at an example. We will now look at an example which is on the other side. The example reads, when 3 resistors, 2 ohms, 4 ohms, 6 ohms are connected in parallel with a voltage source of 33, you are supposed to determine the equivalent resistance. You are supposed to determine the current. You determine the voltage as it reads. So 3 resistors, 2, 4, 6 are connected in parallel with the 3. Find the equivalent resistance, the voltage across the 4 ohm resistor, the current across the 2 ohm resistor, the power dissipated across the 6 ohm resistor. So what do? We will say, let this one be so that is the solution. We are solving that question. So the solution will be, you have to draw this circuit. Remember, we have said this is 2 ohms, this is 4 ohms, and this is 6 ohms. And remember, we have been told the voltage here is 33 volts. If you want to solve such an example, like we have said, the total resistance you will begin with the total resistance. Equivalent resistance means the total resistance. So total, the formula will be 1 over R total will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this will be equal to 1 over 2 plus 1 over 4 plus 1 over 6. Remember, this will be the same as if you take the LCM. If you take the LCM, the LCM will be 12. The LCM will be 12. That is 12. It goes there 6 plus this is 3 plus 2. Remember, this is 1 over R total. This will be the same as 11 over 12. So it means that 1 over R total will be equal to 11 over 12. If you want to know the total resistance, the RT, you take the reciprocal. The reciprocal will be 12 divided by 11 ohms. So the total resistance of the circuit is 12 divided by 11. 12 divided by 11, which is the same as 12 divided by 11, which you will get as 1.091 ohms. We move to number B, the second part, which is the voltage across the 4 ohm resistor. The voltage across the 4 ohm resistor, that is automatic. The voltage will be equal to 33 volts. 33 volts. Remember, we have said voltage is the same across board. So 33 will pass here, 33 will pass there, 33 will pass there. So the voltage across the 4 ohm resistor is that. We move to number C. The current across the 2 ohm resistor. Remember, we have said I2 from Ohm's law is given by V over R2. The voltage across the 2 ohm resistor, this one, 2 ohm resistor is R1, which is I1. So we are supposed to get I1 will be equal to 33 divided by R1, which is 2. If you divide 33 divided by 2, you will get 16.5 amperes. If you move to part D, part D will be equal to the power dissipated across the 6 ohm resistor. How do you get power? Remember, you can decide to get the current across the 6. Remember, we can get the current there. Current across the 6. So meaning that is I3 will be equal to V over R3, which is equal to 33 divided by 6. If you take 33 divided by 6, you will get 5.5 amperes. Remember, what we asked is power. Power is equal to IV, current times voltage. So meaning you will be able to get the current as 5.5 times the voltage, which is 33. So if you multiply by 33, you will get 181.5 watts. Remember, the SI unit of power is that one. Or you can say power is equal to V squared all over R. I think you have these formulas. voltage power is equal to V squared over R. Remember, our voltage is 33 squared divided by the resistance divided by R3. Remember, we are being asked to get the power dissipated across 6 ohm. 6 ohm is R3, so meaning you divide by 6. So 33 squared divided by 6 gives you 181.5 watts as the power there. So that is how you solve that example. We will do more examples as we carry on. We will do more examples as we carry on. For now, those are the values.